Fascinating Frontiers, Episode 40, March 20th, 2026. Hey everyone, welcome to another episode of Fascinating Frontiers. I'm Patrick, coming to you from Vancouver on this beautiful March 20th, 2026. There's so much going on right now in space and science that it feels like the cosmos is putting on a full show for us. Let's dive in. First up, Blue Origin has just filed some truly ambitious plans with regulators. They're looking at building a massive constellation of up to 51,600 satellites designed specifically to host data centers in orbit. This isn't just another satellite swarm. It's a serious push to move some of the planet's most power-hungry computing infrastructure off the ground and into space. What makes this move fascinating is how it reflects the explosive growth in our need for data processing and the creative ways companies are now thinking about where to put that infrastructure. On Earth, data centers are enormous consumers of electricity, and they generate a ton of heat that needs constant cooling. Up in orbit, you get essentially unlimited solar power, and the vacuum of space acts as a natural heat sink, radiating excess warmth away into the cold of the cosmos. It's a clever use of the space environment that could make these facilities far more efficient than anything we can build on the ground. To me, this feels like a major milestone in the evolution of the orbital economy. We started with communication satellites, moved into Earth observation, and now we're seriously talking about turning low Earth orbit into a giant orbiting server farm. It shows how space is rapidly becoming a place for practical, everyday business rather than just science and exploration. I'm genuinely curious to see how this develops over the next few years. While one American company is betting big on the orbital economy, our neighbors to the north are making their own important strategic investment in sovereign space access. The Canadian government has committed $200 million toward building the country's first commercial spaceport, located in Nova Scotia. This facility will be operated by Maritime Launch Services and is aimed at giving Canada an independent launch capability right from our own soil for the first time. For a country with such a proud space heritage, from the Alouette satellite in the 1960s to our current contributions to the International Space Station and the Canadarm, this feels like a long overdue step toward greater self-reliance. It means Canadian-built satellites and scientific payloads could reach orbit without having to book rides on foreign rockets, which adds both flexibility and a measure of sovereignty. I love seeing this kind of investment happening at home because it creates real opportunities for our engineers, technicians, and scientists. Instead of watching launches from Florida or Kazakhstan, we might soon be able to drive down to the East Coast and watch a Canadian rocket lift off from Canadian soil. That's pretty special. It also opens the door for more domestic space companies to grow and for universities to fly their own experiments more easily. This spaceport isn't just about rockets. It's about building an entire ecosystem that keeps Canadian talent and innovation here at home. Speaking of getting to space, NASA is in the middle of one of its most significant hardware movements in years. The towering Space Launch System rocket, standing an impressive 322 feet tall, is being rolled back out to the launch pad at Kennedy Space Center. The whole process from first motion is expected to take about 12 hours, coming after months of careful vehicle assembly and testing inside the vehicle assembly building. This rollout prepares the rocket for the crewed Artemis II mission, currently planned for no earlier than April 1st. On that flight, 4 astronauts will climb aboard the Orion capsule, ride the SLS into space, and then swing around the moon before returning to Earth. It's essentially a dress rehearsal for deep space operations, testing the capsule's life support systems, navigation, and thermal protection under real lunar distance conditions. What makes this flight particularly meaningful is the human element. Unlike the uncrewed Artemis I test, this time there will be people living and working inside the spacecraft for roughly 10 days. Every system has to work perfectly when lives are on the line. The engineering challenges involved in making a rocket this large and complex safe for humans are immense, yet here we are watching the hardware slowly make its way to the pad. It's one of those quiet but powerful moments where decades of work suddenly feel very real. While we're gearing up to send humans back toward the moon, some truly strange worlds out there are reminding us just how weird planets can get. Astronomers continue to be puzzled by a class of extremely low-density cotton candy exoplanets that seem to be shrouded in a mysterious haze so thick that even the powerful James Webb Space Telescope can't penetrate it to analyze their atmospheres. These planets rank among the least dense worlds we've ever discovered, which makes them incredible test cases for our theories about how planets form and evolve. The fact that JWST's sophisticated infrared instruments are being blocked by this haze tells us that some planetary atmospheres are far more complex than we anticipated. It's forcing scientists to think about new observation techniques and perhaps even new models for how these fluffy atmospheres behave. Understanding these strange worlds isn't just about satisfying curiosity, it helps us piece together the bigger picture of planetary formation across the galaxy. Every time we find a planet that breaks our expectations, it refines our understanding of what's possible. These cotton candy worlds are a perfect example of how the universe keeps surprising us and how much we still have to learn. Staying with exotic physics, astronomers have finally cracked the mystery behind one of the strangest radio signals in the sky. New research has shown that the Crab pulsar's unusual zebra pattern radio emissions come from a fascinating tug-of-war between gravity and magnetism happening inside the pulsar's magnetosphere. Gravity focuses the radio signal into tight beams, while clouds of plasma act like a defocusing lens, creating the distinctive striped pattern we observe. This helps explain why the Crab's signals look so different from the broad, noisy emissions coming from most other pulsars. The discovery emerged from detailed modeling of the extreme environment right above the neutron star's surface. Let me take you a little deeper into that environment because it really is mind-blowing. If you could somehow squeeze the entire mass of our sun down into a sphere roughly the size of a city, you'd have a neutron star. A single teaspoon of its material would weigh about 1 billion tons here on Earth. Right after a radio photon forms near the surface, the star's magnetic field, which is trillions of times stronger than Earth's, grabs hold of it and tries to whip it along the magnetic field lines at nearly the speed of light. At the same time, the star's enormous gravity bends space-time so severely that it acts like an immense natural lens, focusing those photons into incredibly tight beams. Meanwhile, the plasma trapped in that magnetosphere pushes back, scattering and defocusing the signal in this constant cosmic tug-of-war. Temperatures in these regions can exceed 1 million degrees, and the magnetic fields near the poles reach strengths that would literally rip atoms apart. We can watch the resulting lighthouse-like pulses sweep past Earth with exquisite precision, yet the exact mechanism that produces the zebra-like fine structure in the Crab's radio spectrum remained a puzzle until very recently. What keeps astronomers up at night is how these competing forces create such stable, repeatable patterns over thousands of years, and whether similar physics plays out in magnetars where the magnetic fields are even more extreme. It's a beautiful example of how theory and observation can finally come together to explain something that seemed almost magical. Coming back a little closer to home, the Hubble Space Telescope recently caught Comet K1 in the early stages of disintegration after it passed perihelion. Astronomers had originally planned to observe a different target, but when that observation became unavailable, they quickly pivoted to this comet and ended up recording a rare breakup event in real time. The images show the comet beginning to fall apart after its close brush with the sun, with material visibly shedding from its nucleus. Hubble's sharp vision gives us an incredible front-row seat to these dynamic processes that shape comets over their lifetimes. Moments like this remind me how fortunate we are to have long-lived observatories like Hubble still operating in orbit, ready to seize unexpected scientific opportunities. Watching a comet come apart in real time feels both dramatic and deeply informative. It's a window into the violent processes that have been happening in our solar system for billions of years. While Hubble was watching that dying comet, we have a beautiful observing opportunity happening right in our own sky this week. A young crescent moon hanging low after sunset will show its dark side, gently illuminated by earthshine. This soft, secondhand light lets you see features on the lunar surface that are normally hidden during the moon's thin phase. It's one of those easy, backyard observing treats that doesn't require any special equipment at all. You can just step outside, look low in the western sky shortly after sunset, and see the faint outline of the full lunar disk glowing softly against the twilight. Earthshine is essentially sunlight that has bounced off our own planet and then reflected back onto the moon. There's something wonderfully peaceful about it, a quiet reminder that even when we're looking at the moon, we're also seeing a reflected image of Earth's own light. I always encourage people to take a few minutes to enjoy this when it's visible. It's astronomy at its most accessible. Speaking of ancient material, new images are revealing fascinating secrets inside the asteroid samples we brought back to Earth from asteroid Bennu. Using advanced imaging techniques, researchers have discovered extensive networks of cracks running through the particles collected by the OSIRIS-REx mission. These findings are giving us fresh insight into the internal structure of this primitive asteroid material. Bennu is essentially a time capsule from the very early days of the solar system, and those cracks tell us important stories about the stresses and impacts the asteroid has experienced over billions of years. Understanding the building blocks of our solar system like this helps us learn how planets formed and how water and organic material may have been delivered to the early Earth. It's remarkable to think that from just a few grams of material collected millions of kilometers away, we can reconstruct such detailed chapters of solar system history. While we figure out the stories locked inside these ancient rocks, there's growing concern about protecting the places we've already reached in space. With more than 100 new lunar missions expected over the next decade, experts are urging stronger protection for historic sites like the Luna 2 impact location and the Apollo landing areas. A recent summit brought together specialists to examine legal, scientific, and engineering approaches to preserving the more than 100 metric tons of human-made material already sitting on the lunar surface. These sites represent important milestones in human exploration and deserve to be treated with care as we return to the moon. As more countries and private companies head there, finding ways to avoid damaging this shared heritage becomes increasingly important. It's a conversation that beautifully blends science, policy, and respect for what previous generations accomplished. I find it encouraging that we're thinking about preservation even as we prepare for the next big wave of lunar exploration. Staying in the world of satellites and orbital infrastructure, two companies are teaming up to help clean up the clutter around Earth. Portal Space Systems and the Australian startup Paladin Space have announced a collaboration to offer a commercial orbital debris removal service. The partnership brings together Portal's maneuverable spacecraft technology with Paladin's specialized debris capture expertise. It's an encouraging sign that commercial solutions are starting to emerge for the growing problem of space junk. Reducing the amount of debris in orbit will help keep pathways safer for future satellites and crewed missions. I'm genuinely glad to see innovation focused on keeping space sustainable for the long term rather than just rushing to launch more hardware. And finally, artificial intelligence is quietly reshaping how we do astronomy. The technology is transforming everything from how we process telescope images to the way we discover new objects and patterns in enormous data sets. It allows researchers to spot subtle signals and connections that might otherwise be missed in the flood of information coming from modern observatories. This partnership between human curiosity and machine learning feels like a powerful next step for the field. AI isn't replacing astronomers. It's giving them superpowers to explore the universe more effectively than ever before. Before we wrap up, keep an eye on that SLS rocket as it continues its testing and preparation for the crewed Artemis 2 mission. It's going to be an exciting few weeks ahead. That covers today's tour of what's happening in space and science. If you enjoyed the episode, please share it with a fellow space enthusiast. These discoveries are always more fun when you can talk about them with someone else. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow for more fascinating frontiers. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.
Drifting softly through the black.